this project, we will simulate a solar heater of a water tank and the effect of PCM inside it. In this project, using PCM encapsulated in a water tank solar heater has been investigated with different considerations, including the effect of melting and freezing temperature of PCM material, the effect of PCM material volume, and a comparison with no PCM material. The geometry of the present project is designed in ANSYS Design Modeler software and includes the water storage chamber for the solar water heater. The present project is meshed in ANSYS meshing software, and the mesh type used for this geometry is unstructured.
By clicking on the subscribe button, you will be informed about the newest CFD training videos by Mr. CFD. Or if you are watching the training video, click on the Mr. CFD logo and subscribe.
A new window will appear showing you the domain extents of your geometry. Also, under the view length unit section, you can see the default geometry units, which is meter in this project. Also, under the scaling section, under the mesh was created in, you can change the settings in order to activate the scaling factors beneath that. For example, your geometry and mesh was designed in a software which its default unit was millimeters. By activating these scaling factors, you can change this factor to your desired factors in order to set the length to the appropriate unit. Now, if you expand the fluid under the material section, you can see that this material, which is a PCM, is defined here. Now, if you double click on this material, a new window will appear showing the properties of this material. And finally, for the outer wall boundary, you can see that the heat flux thermal condition is selected, and the value of heat flux applied on this wall boundary is equal to 0, which means that this wall is adiabatic. After double-clicking on the controls button, in the middle section of the software window, you can see that new part will appear. In the appear part, you can see under relaxation factors for different parameters. Now, these values are set here by the software automatically. You can change these values, which are between 0 and 1, by yourself for different projects you do. But it is highly recommended that you do not do that, since it may result in divergence. Now, if you expand the report definition section and double-click on the last item in the appeared window, you can see that an area-weighted average report is defined over the field variable of solidification or melting, or specifically liquid fraction. And under the surfaces section, we can see that we have selected the interior surface. Now, this report shows the liquid fraction changes over time inside our computational domain. Now, in this contour, you can easily see the changes of the liquid fraction of the PCM inside our computational domain. And in this slide, you can see the temperature changes inside our computational domain at the end of our simulation process. Now, in this slide, you can easily see the streamlines inside our computational domain, and you can easily see the role of natural convection in the motion of our streamlines. Finally, a summary of different settings and setup that we have used in our project is presented to you in the slide.
Obtain the mesh file and also the full training movie by purchasing this product.
Phase change materials can change phase, for example from solid to liquid and vice versa, over an almost constant temperature range. The phase change process in such material is usually accompanied by the exchange of large volume of energy, which is referred to as latent phase change heat. This high volume of heat is exchanged in harmony with nature and automatically and intelligently through ambient temperature changes. These materials have become one of the special capacities of energy storage in various uses due to the mentioned properties like solar heater. Due to the increasing need for energy and limitation of fossil fuels, which are a depleting source and polluting the environment, the need to use new energy sources is felt more than ever. One of the most widely used energies is solar energy. The use of PCM phase-changing materials with high latent heat is suitable for storing thermal energy, especially solar energy, which has been very popular in recent years. Meanwhile, phase change materials in the water tank related to solar water heaters are a new method that has recently been considered. In this project, using PCM encapsulated in a water tank solar heater has been investigated with different considerations, including the effect of melting and freezing temperature of PCM material, the effect of PCM material volume, and a comparison with no PCM material. The PCM space's inner wall is considered a wall with a temperature condition of 603.3 Kelvin and a thickness of 1.5 mm. For the outer wall of this space, the wall boundary condition with adiabatic condition is used. The energy equation is activated to obtain temperature distribution inside the computational domain, and the laminar model is exploited to solve fluid flow equation. The solidification or melting model has been used to analyze the phase change of PCM material from solid to liquid and vice versa due to the temperature change inside the water storage area. You should apply the Boussinesq model to determine the density changes in proportion of temperature. To benefit from Mr. CFD services including simulation, consultation, and training, contact our experts via info@mrcfd.com.